All right, today we're going to talk about graphs of polar curves again, but we're going to talk about some special curves called rose curves. And we talked last time about r equals cosine theta, and um, I happen to have here on Desmos our r equals cosine theta, which is a circle of radius 1 centered at 1/2 0. Um, and in polar coordinates, or the polar equation, that is the circle. Okay, but what happens if we change the period factor? Let's say instead of, b equaling 1, we change the period factor, make it 2, and then the period now is 2 pi over 2, which means the period is now pi. So what happens to the graph when we do that? Well, let's see. Wow. It makes it into what we call a rose curve. Now this rose curve has 4 petals, we call it. 1, 2, 3, 4 petals. And the length of each petal is 1. And it happens to be the amplitude, because r is how far you go out radially. Let's say theta is 0. The cosine of 0 is 1. So you would go out radially 1 and rotate 0. And you would be at this point right here. So the petals are of length 1, which is the amplitude of our curve here. And we have 4 petals. That's interesting. So what happens if I change the period factor from instead b equals 2 to b equals 3? Well, they all call this a rose curve also, even though it doesn't look quite like a rose. But how many petals does this one have? Well, this one has 3 petals, and its petal length is still 1, which is still the amplitude of this curve. But this one has 4. Interesting. So let's see if we can see a pattern here. All right, so what happens when I change the b factor from 3 to 4? Oh my goodness. Well, now this definitely looks like a flower. Maybe not a rose per se, but it's a flower. And look at the petal lengths are still 1, which are the amplitude, which is the amplitude of this curve. But now how many petals do we have? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8 petals, with a period factor b equaling 4. So when I had a period factor of 2, I had 4 petals. When I had a period factor of 4, we had 8 petals. So let's see if we can predict how many petals we're going to have if we have a period factor of 6. Well, if 2 gives us 4 petals, 4 gives us 8 petals. I'm hearing it from the back of the room back there. Let's see. Oh, I heard a big 12 petals. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 petals. And you were right back there in the back. So it appears as though we can predict the number of petals our rose curve will have based on the number, or whatever the period factor is in here. All right, so let's see what happens when I am 3. But that doesn't go for 3, does it? Because here I have 3 petals. So let's see what happens when we do 5. Now some might expect 10. 1, 2, 3, 4, 5. Still of length 1, still the coefficient, the a, the amplitude. So if we have 5 cosine 5 theta, we have 5 petals on this rose. So if we were predicting, how many petals would we see for a cosine of 7 theta? Oh, everybody said in unison, 7, Mrs. Muller, we should see 7. Let's see, let's count. 1, 2, 3, 4, 5, 6, 7. Absolutely. you'd see 7 petals. So it appears to be, the pattern is, if you have an even number here, and what I'm going to do is generic. So we're going to go R equals, we'll say cosine of n times theta, and I want a slider just for n theta. Okay, and so if n starts, oh no, yeah, well that's fine. I want my slider, right now my slider is n equals 1. And I'm going to set my slider to start at n equals 1, and we'll make it go to 20, and then we'll put the step in increments of 1. And let's see what happens to our curve. Oh, wow. Amazing. So every even number, we're going to have double the number of the period factor petals. For every odd, we're going to have exactly the same number as the period factor of petals, which is pretty cool. Okay, so we love to study polar curves because they're relations, obviously, but they are cool looking curves and they're fun to draw. Okay, I stopped at 7. All right, now usually I have a wise cracker back in the back who says, well, but Mrs. Muller, you're doing integers. What if the period factor is not an integer? Well, let's see what happens. Got to take care of those folks. Let's say cosine of, I don't know, 1.5, because somebody might say 1.5 times theta. Oh, now that's fascinating. And let's see if we go from theta equals, I don't know, 6 pi. All right, well, that's pretty cool. Let's see if we make it a different decimal. So they overlap. Do you notice that these curves over here do not overlap? Okay, so these overlap if you have a decimal. Let's see what else happens. Let's go 2.15. Ooh, even cooler, huh? So we could play around with these things all day. What if we had a period factor of pi, right? Ooh, even cooler, right? So we can have so much fun creating polar curves. I just wanted to give you a little bit of taste of what happens if you have a period factor that's not an integer, because they can come up with some really neat graphs. But for our purposes, we're going to learn how to graph these polar rose curves with period factors that are integers, so that we'll know the number of petals, we'll know their petal length, and have some fun doing that. Okay, all right, so the very first one we're going to do, if you printed the guided notes, let's go to my IPvo here so you can see what I'm doing. Here are the guided notes for today, and it's titled Rose Curves, etc., which means we're going to get into some cool things a little bit later, further on in the discussion here. Let me get this unblurry here. All right, here we go. I am given the curve r equals 3 cosine 2 theta. Now, I want you to graph the curve in an r theta plane, just like we did with the other curves, the limicons, and the dimpled limicons, the convex limicons, the cardioids, etc. I like to see this because then we can pick the polar points off of here and graph them here. I think that's powerful stuff. But what have we changed here? Now we have a period factor, or a b, of 2. So we have to say the period, these are my little scratch notes here. The period here is 2 pi over 2, which is pi. And I got to know the increment in order to graph my curve. So the increment's going to be the period times a fourth, which is going to be pi over 4. And these are all with no phase shift and no shift up or down, vertical shift. So we're going to go to pi, and this is pi over 2, pi over 4 here. Now, ordinarily, we would do this, but I know that the unit circle here pretty well, and I know you guys do too. All right, so let's graph 2 periods and see if we need them. So 2 pi here, halfway is going to be 3 pi over 2. And then we have 5 pi over 4. and then 7 pi over 4. And now the amplitude we know is 3, so we're going to go up 3, down 3. And this is a cosine curve. The cosine curve starts up in amplitude and goes back to the midline, goes down in amplitude, back to the midline, and back up in amplitude. And I'm going to keep going here to get our curve complete here with 2 periods. I'm going to try to hit every point. Not always good at that when I'm doing it live, but there we go. There's our curve. And just like we did on the cardioids and such, I'm going to do an R theta chart. Now R is 3 here, and theta is 0. And then we go to R is 0, and theta is pi over 4. And then we say R is negative 3, and theta is pi over 2. And then R is 0, and then theta is 3 pi over 4. Then we go to R is 3 at pi. And let's see what we got here, and then maybe we'll need to graph some more. So what happens is I'm going to take this number in polar form and go out radially 3, 1, 2, 3, and not rotate at all. So I'm starting here. And remembering that our theta is going positive, so all my rotations are going to be counterclockwise because I'm going in the positive direction here. Okay? All right, so this means I'm going from a radius of 3 back to, this is the pole, and this is the pole. But I have to be back to the pole, and R is getting smaller here, it's decreasing. I have to be back to the pole by pi over 4. Now I'm going to put a little dashed line here. Let's do it in a different color so you can see it. Not part of my curve. Okay? Pi over 4. So I have to be back to the pole by pi over 4. So R is getting smaller, but here we go. I made it back to the pole before pi over 4. And then the next point I'm going to go to is negative 3 out radially, 1, 2, 3, and then positive pi over 2 rotation here. So I'm going to pass through the pole to get to this next point. Pass through the pole to get to this next point. And now I'm going to head back to the pole, before 3 pi over 2. So this is the angle here, pi over 4. So I'm going to go back to the pole here. And then my next point is 3, go radially out 3, and then rotate to pi. And so I'm going to pass through the pole, and then R is getting bigger until I get here. The magnitude of R is getting bigger. But I'm not done yet because I already know from what we discovered with our graphing just a moment ago that how many petals am I going to have? I'm going to have 4 petals because I have an even period factor. So I need to keep going here. So let's do some more R's and thetas. So I start at pi, and then I go back to the pole, and then that's at pi over 4. Then I go back to negative 3, and then rotate 3 pi over 2. Then back to the pole, back to the pole at 7 pi over 4. And then at 2 pi, my R is 3. So let's see what happens when I graph these points. Okay, so we stopped at pi here. So my next point is I'm going to pass through the pole because remember this is the pole. And I'm going to have to head to this point, which is negative 3, 3 pi over 2. So let's go to negative 3, and then rotating positive 3 pi over 2 means pi over 2, pi to 3 pi over 2. So I'm going to end up here. So I have to go back to the pole before pi over 4, and then up to that point. And then what happens? I have to head back to the pole before 7 pi over 4, which is going to be this pi over 4 angle. So I have to head back to the pole. Now these do not overlap here, even though it might appear so in my picture. They shouldn't overlap. Okay, and then we go from 3. This is where we're ending. 3, and then I rotate 2 pi. Well, that just puts me where I started. So then I have to go back from the pole to here. So there we have it. We have our, I was going to write rose curve here. The rose starts with R. So rose curve with 3 petals. And what is the petal length? That means from here to here, the petal length is 3 because that's our amplitude. And where is the maximum R value going to occur? Or the magnitude of the largest Y value going to occur? Well, it's going to occur at 0, pi over 2. See, it's 0, pi over 2. Do you see how this distance here is 3? This distance here is 3. This distance here is 3. This distance here is 3. So in effect, this is a partial petal. This is the whole petal, petal, petal. Do you see how that's working? So you have 1, 2, 3, and these two are halves of petals, which is how we ended up drawing that. Okay? So we just drew our first rose curve. So the maximum R occurs at theta equals, what is it, 0, pi over 2, pi, and 3 pi over 2. I'm running out of space. How's that for trying to squeeze it in? Okay. All right, so let's see what happens now when I do it with a sine curve and see how it's different than the cosine of 2 theta. All right, so my period is the same, my increment is the same because my b factor is 2. So I'm not going to write those out again, but I have a midline of 0, and I'm going to go all the way to 2 pi, and then halfway is pi, and then halfway is pi over 2, and then halves and halves. Right, and this is pi over 4, and this is 3 pi over 4, and then we have, in the middle here, we have 5 pi over 4, 3 pi over 2, and 7 pi over 4. All right, and my amplitude is again 3, except now, instead of having a cosine curve that starts up in amplitude off the midline, I have a sine curve that starts on the midline. And since it's a positive sine curve, it's going to go up in amplitude, back down to the midline, down in amplitude, and back to the midline. And then we're going to repeat the, the whole thing over again. Here we go. We're going to connect all the dots. And I almost made it through all my dots. But that's all right. Knowing again that this is R and theta. So let's do an R theta chart. And by the end of this video, I'm hoping that we'll get to the point where we don't need this R theta chart. We can just read the polar points off of this graph. But for the first page and a half, we're going to do an R theta chart because I think that'll help. Again, we're expecting how many petals? 4 petals because we have an even number b factor. So my first polar point is 0, 0. Then I have a radius, an R of 3, and then an angle of pi over 4. And then I go back to the pole. Remembering these are the pole. When you're at R is 0, you're at the pole. This would be pi over 2. And then I'm at negative 3, 3 pi over 4. Let's keep going here. And we're back at the pole at pi. And then we're at 3 at 5 pi over 4. And let's keep going because I know I need two full periods to get the whole thing. So then we go to 0, we go back to the pole, and this is 3 pi over 2. And then we go to negative 3 at 7 pi over 4. And then we're back to the pole at 2 pi. All right, so what's our first polar point? Our first polar point is 0, 0. So we start at the pole. And then I'm going to go out radially, 1, 2, 3, and rotate to pi over 4. Now remember, these on the polar plane are in 12ths. So this is, the first one is pi over 12. This one's pi over 6. This one would be pi over 4. So the very middle one is pi over 4. Okay. And so there we go. And then I have to head back to the pole before pi over 2. I'm remembering that this is pi over 2. So I'm going to go out, hit my max petal length, and then go back to the pole. So I went out to my max petal length and came back to the pole. All right. Now I'm at the pole at pi over 2. Now I'm going to go out radially, -3, 1, 2, 3. Rotate 3 pi over 4. Since remembering theta is this direction positive, which means I'm going counterclockwise. 3 pi over 4 is going to be, 1, 2, 3, I lost my space. Okay, so then I'm going to go, this is pi over 4, and then this one would be 3 pi over 4. So what's going to happen is I'm going to go from this point out here, pass through the pole, and end up at this point. So here we go. We're going to pass through the pole and end up at this point. And then what happens? I have to head back to the pole. Head back to the pole. But where do I have to end up? I have to end up at 3, 1, 2, 3, and then rotate 5 pi over 4, which is going to put me, this is 3 pi over 4, this would be 5 pi over 4 here. So I'm going to pass through the pole and then hit this point. And then I go back to the pole. And then I go out radially, -3, 1, 2, 3. And 7 pi over 4 is all the way back around in here. So I'm going to pass through the pole from here, hit this point, and then head home back to the pole. And there is my rose curve with 3 petals of length 3. Of length 3. Now, what's the difference? Do you notice that cosine starts off the midline and up in amplitude? Well, this curve, when we first drew it, started off the pole, right? Because this right here is r equals 0. This is the pole. So this started off the pole and to the right. This sine curve started on the pole, off the pole, on the pole. So all of the leaves are not on any of the axes there. But here they are. So that's interesting, right? So remember, if sine starts on the pole, cosine starts off the pole. Now, where do the max magnitudes of r occur here? What thetas? Well, at pi over 4, at 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now let's see if that makes sense in our graph. Is this pi over 4? Yes. 3 pi over 4? Yes. 5 pi over 4 and 7 pi over 4? Yes. And they all have the max petal length occurring there, which is really neat. Okay, and which petal did I graph out first? Well, I graphed out this petal first, so I'm going to put a little 1 on this one. I graphed this one out first, and then where did I go? I went through the pole and then headed over here. So then this one was second, this one was third, and this one was last. You can't really see my numbers here. Okay, so this one would be petal 1, petal 2, petal 3, and then petal 4, which is really neat. Okay, let's do one where we have an odd B factor here. So I have to change my period here. So the period is equal to 2 pi over B, which is 2 pi over 3 in this case. The increment is going to be 2 pi over 3 times 1/4, which is, if you multiply that out, you get 2 pi over 12, which is pi over 6. And since these are different values here in the denominator, I'm going to find a common denominator here, and this is going to equal 4 pi over 6. And so my period is 4 pi over 6. And I'm not going to reduce here until we get to the graph part, okay? And so my increments are in pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6. And I'm going to go further because I know we're going to need more. And since we know we have 3 petals, we know we're going to have to go out further. So let's see what happens here. This is going to be another period, which would be 4 pi over 6 plus 4 pi over 6, which is 8 pi over 6. Halfway, halfway, halfway. And then we're going to have 5 pi over 6, 6 pi over 6, and 7 pi over 6. And this has got an amplitude. I switched it up to 4 to be a little bit different so that we could at least see them. So I made it bigger this time. Okay, so for cosine, cosine starts off. That's right, off the midline and up in amplitude. So we're going to put a point here. Back to the midline, down in amplitude, back to the midline, up in amplitude. Well, that's not quite an amplitude. I'm getting there. Down to the midline, down in amplitude, back to the midline, and we end up off the midline here. So here we go. I'm going to try to hit all my points. Either way, you get the point, right? Ha 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 ha. Okay. Anyway. All right, so let's do an R theta chart. First of all, how many petals are we expecting? Well, expecting 3, aren't we? So where do you think we're going to have to stop? Well, I'm going to suggest to you that this is a petal, full petal here. This is a full petal. And this is a full petal, but I started with half a petal. So I'm probably going to have to stop maybe here, but we'll see. Let's predict. All right, so R theta. My first R is 4, my theta is 0. My second R is 0, theta is pi over 6. Then I go to negative 4, 2 pi over 6, which happens to be pi over 3. And this is where I do my conversions typically. Okay, and then we're going to go back to the pole at 3 pi over 6, which is pi over 2. Then we're going to go back up to 4 at the angle of 4 pi over 6, which reduces to 2 pi over 3. Then back to the pole at, that's 5 pi over 6. And one more. So we go to negative 4 at pi, because that's 6 pi over 6. Then back to the pole at 7 pi over 6. And then we're back up to the top there at 8 pi over 6, which is 4 pi over 3. All right, so let's graph our curve. So we're going to start out radially 4, 1, 2, 3, 4. And then we have to go back to the pole by pi over 6. So where is pi over 6? Remembering pi over 6 is this line. That's theta equals pi over 6. So I have to, my R is getting smaller until I get to 0. So I have to approach the R getting smaller until I get to 0 there at pi over 6. Okay? Then where's the next point I'm headed to? I pass through the pole because he's changed signs here. And then I go negative 4, 1, 2, 3, 4, and rotate pi over 3. So if I'm rotating in the positive direction, that's down here because that's counterclockwise. I'm going to end up here. 1, 2, 3, 4. I didn't count the right. Okay. So I'm going to pass through the pole and end up here. That's that point right here. That's negative 4 pi over 3. Then I got to go back to the pole before I get to pi over 2, which is down here. Then I go out radially 4, and then I have to rotate to the next point, which is at 2 pi over 3, which is right here. There we go. And then I go back to the pole before I get to 5 pi over 6, which is right here. And then I go negative 4, 1, 2, 3, out radially, and then I rotate pi. So I'm going to pass through the pole and then hit pi. So that's, I guessed right, didn't I? Where we had to, so this is half a petal, this is a full petal, this is a full petal, and then this is a half a petal. And I know that I'm going to have a rose curve with 3 petals. Of length 4 now because my amplitude is 4. And where is my maximum magnitude of R? Now let's see if it worked out on our curve. Oops, I can't spell max. Right, the magnitude of R is the biggest at 0. That's at theta equals 0. And that looks like pi over 3. What is this, 2 pi over 3? And at pi. Now, pi over 3 is a little bit of a deception because this is pi over 3 from -4, isn't it? So, right? So this, we've got to remember in our back of our minds that that's happening when we're at -4 rotation out, okay? So let's see if we're right. At 0, do I have a maximum r? Sure. At -4, pi over 3, do I have a maximum r? Yes. What about at pi? Well, I'm again at pi, I'm at a -4. So if I'm over here, yes, I have a maximum here. So that's pretty cool that you can kind of predict where your curve is going to be based on the maximum r values that you have over here. All right, let's do another one. What happens if it's a sine curve? Now, can we predict? Remember, we said that the cosine up here starts off the pole, out in amplitude, right? Off the pole and out in amplitude. The sine curve here started at the pole and then went out to the amplitude. So this is a cosine curve that started out off the pole and out in amplitude. So did it start out off the pole, up in amplitude, out in amplitude? Yes. And then went back to the pole. So where's this one going to start? I heard it. Yes, it's going to start at the pole. Now, I'm not going to do the period and increment for this one again because I already did it, right? Because this is a 3 and this is a 3 also for the period factor. So that's going to be the same curve parameters here on the right side. The only difference is that our curve now is going to be starting on the midline. So let's draw it out. It'll take us a few minutes to get that done, but here we go. We're going to go to 4 pi over 6, and then 8 pi over 6. Maybe I'll spread it out a little bit. And then half, 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 and this is going to be pi over 6. 2 pi over 6, 3 pi over 6, and then halfway, half, half. This is 5 pi over 6, 6 pi over 6, and 7 pi over 6. I'm a little bit OCD about, going out and then taking half and then half again. I'm better at drawing my increments that way. It helps me out a lot. So bear with me. All right, so this curve has an amplitude of 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is -4 and this is 4. And you guys were right. It starts at the pole, which is 0. And then I'm going to go up in amplitude, back to the midline, down in amplitude, back to the midline, up in amplitude, back to the midline, down in amplitude, back to the midline. And I'm going to connect my dots. Yay, it looks like I'm going to hit them all. Famous last words. I got them all. So how many petals are we going to predict this one has? It's going to have 3 petals. It will. So I think all I need to graph is 1 full petal, 2 full petals, and 3 full petals. So I think we're going to stop at the same spot at pi, okay? So let's see if we can read the polar points now off of this graph. Remembering that r goes first. Okay, if r goes first, I'm at the pole, 0, 0. Then I'm going to go out radially 4, 1, 2, 3, 4, and rotate to pi over 6. So pi over 6, we have to remember, is the second line. So I'm going to go out radially to pi over 6, and then before I get to 2 pi over 6, which is pi over 3, I'm going to put this pi over 3 here. It might help if we have all the pi over 3s on here. You're going to go back to the pole before you get to pi over 3, because the pole is at pi over 3. Then I'm going to pass through the pole, and then my next point is -4. 1, 2, 3, 4. -4, and I'm going to rotate 3 pi over 6 or pi over 2, so I'm going to end up here. So I'm going to pass through the pole, and then I'm going to go out to this next point here. There we go. Out to this next point. Then head back at the pole before I get to 2 pi over 3. So this would be 2 pi over 3 here. So I'm going to head back to the pole. And then I'm going to go radially out 4 and rotate 5 pi over 6. So 1, 2, 3, 4, and rotate. Oops, I'm sorry. 1, 2, 3, 4. And rotate to 5 pi over 6, which is right here. Rotate to 5 pi over 6. And go out radially. Okay, and then we're going to go back to the pole at 6 pi over 6. which is pi. And there's my sine curve. This is a rose, again, a rose curve with 3 petals of length 4, where the max magnitude of r is going to occur at theta equals, that's going to be pi over 6. I'm going to say negative pi over 2 because we're down south here. And then at 5 pi over 6, and then negative 7 pi over 6. I think that's going to be an easier way to think about it. Okay, so let's see if our graph correlates with that. At pi over 6, there we go. I have a max r. That's the petal length. At negative pi over 2, there we go. We have a max r. 5 pi over 6, I rotate this way. There's 5 pi over 6. I have a max r. Very nice. And then 7 pi over 6, negative. So if I would start at negative pi, so I'm going to go negative 7 pi over 6. I'm back where I started again, you see? Pretty cool. All right, so that works. Neat stuff. So we graphed 4 polar curves, different b factors. All right, so what happens then if I make my leading coefficient, which is the next one, negative? Now what you're going to find is if I make the leading coefficient here negative, it's going to give you the same graph, because this is reflective all over the place, isn't it? I mean, it's reflected up, down, left, right. So if it's negative, it's still going to be the same curve. You just start over here instead of over here when you graph it. So this one is a little bit trickier in my opinion, so we're going to talk about it. This is still a 3-petal rose, and I know that the period is the same as the ones we just did, the 2 we just did previously, which means it's 4 pi over 6. So let me write that down. 4 pi over 6, and then 8 pi over 6 is the next period. And so we're going to go half, 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 and this would be pi over 6, 2 pi over 6, 3 pi over 6, and then halfway, half, half. This would be 5 pi over 6, 6 pi over 6, and 7 pi over 6. Nice review of our graphing our trig functions. So negative 4 and 4, so our amplitude is 4. Our midline is still 0, and this is a cosine curve, so we're going to start up in amplitude and off the midline. So we're going to start up here, hit the midline, down in amplitude, up to the midline, up in amplitude, back down to the midline, down in amplitude, back to the midline, and end up here. All right. Now we have an odd B factor. So how many petals do we expect? 3. So this is half a petal here. This is a full petal, another full petal, and a half. So I think I only have to go up to pi to graph this. All right, so I'm going to challenge you to do it without an R theta chart, but if you want to do an R theta chart, that's fine. But I think that you'll get to the point where you don't need to do that. So R here, and this is theta, and remembering that theta is counterclockwise because R is, theta is getting bigger, more positive. And we're rotating positively. My first polar point is 4 with an angle of 0. So I've got ready to leave 4. 1, 2, 3, 4. Rotate nothing. Oh, wait. You should have caught me. You were right. I heard it. This curve needs to be what? Upside down. Mrs. Muller was so excited about getting going. She totally realized now that it has to be upside down. That's why in math we have one of these. It's called a big eraser because we do make mistakes and we're human. You know, one of these days I'm going to make a video where I don't have a mistake. That would be something else, wouldn't it? I mean, I might have to throw a party then. Bring in cupcakes and cookies and all those things we really shouldn't eat. That's all right. I just wanted to label some axes again. And I should have listened to you guys. I heard you in the background going, Mrs. Muller, it really is a negative. It's upside down. And then I get going and you can't stop me. Well, good news is that I stopped myself because I was like, oh gosh, I'm starting here again. Well, that's boring. I already did that. All right. So let's start again. This is a negative cosine graph. So we're going to start down in amplitude and off the midline. Back to the midline. Up, down, way down, midline, up, midline, down. I feel much better now. Now watch me not hit all the dots. Oh, the points. Well, I did a better job there. All right, but still, let's talk about the number of petals. We expect how many petals? Oh, well, we expect 3 petals because we have an odd factor, period factor. A B is 3. So this would be half a petal. This would be a whole petal. This would be a whole petal. And I think I only have to go to pi because this is another half petal. All right, so let's graph it. I'm going to start at -4. 1, 2, 3, 4. Relief. Yes, -4. And then I got to go back to the pole. So before pi over 6, I'm going to put my little angle here. This is pi over 6. And here's my other pi over 6, because that's going to help us guide our curve a little bit. I have to head back to the pole. R is getting smaller in magnitude until I get back to the pole. So here we go, before I hit pi over 6. And then we're going to go, I'm going to pass through the pole. I'm passing through the pole here, and then I'm going to end up at 1, 2, 3, 4. 1, 2, 3, 4, can I count? And then to pi over 3, which is right here. So radially, I'm going to go out 4 and rotate. I'm going to end up at this polar point. And then back to the pole again. Here we go, back to the pole again. And then I'm going to go out radially -4 and rotate. That's 3 pi over 6, which is, I'm sorry, I can't even read my own handwriting. That's 4 pi over 6, right? I'm rotating 2 pi over 3. And so 1, 2, 3, 4. I have to end up here. So I'm going to pass through and end here. That's a 4 pi over 6. So it's 2 pi over 3. And then I'm going to go back through the pole. So go back through the pole before I get to the pi over 6 angle here. And then I'm going to go out radially 4. 1, 2, 3, 4, and rotate pi, which puts me back home again. So from this location, I'm going to pass through the pole and hit that curve there. Now, I really should be underneath this line here because these are all pi over 6 angles. But so what's the difference? My cosine curve was negative. So I started off the pole, which I did on this first one, but I started on the negative side. This curve's going to drive me crazy because it goes a little bit beyond 4. Really can't, right? Because it's not bigger than 4. Okay, so what's the difference? I'm going to pull them both up here. This one was the, oops, sorry. This one was the positive cosine. It started off the pole and to the right because this was a +4 radially. This one starts off of the pole and to the left because we started at -4. But it still has 3 petals, rose curve with 3 petals. Of length 4. And where are max magnitude of r's at? Theta equals, well, that's going to be -0, but 0 is no sign. And then this is going to be at pi over 3, and then -2 pi over 3, and then at pi. Now let's see if that works. At 0, do I have a negative? Sure. I mean, do I have a maximum petal? Sure. And then pi over 3, yes. And then oh man, it's opposite, isn't it? It's 0. No, that's all right. 0. Let's see, 0 would be over here. And it's not over here because this is a -4. So it's going to be a bit like a negative here. But then pi over 3, we definitely have one. And then -2 pi over 3. We really shouldn't have a -2 pi over 3, should we? How am I going to do that? It's negative a -2 pi over 3. Over here. Yeah, that's 2 pi over 3. But anyway, it's pretty simple once you realize that, -4, you got to go 2 pi over 3. That's where you should have your maximum. So we should put pi over 3, 2 pi over 3. And then at pi, we have a maximum R value. It helps sometimes if you know where these are, because then you know what angles you have to be here. But it's really simple to pull these polar points off. All right, so goodness gracious, our sine curve starts off the pole, doesn't it? But it's negative, and I promise to go down this time. Maybe. The period is the same, so we're going to have all the same values for our line here. It's going so well, and then that one I messed up. All right, I'm going to try to forget myself. Here we go. Keep going here. All right, this is theta, and this is r. And our amplitude is still 4. -4 and 4 here. All right, so this is a sine curve. Starts on the midline, but we're going down. Yes, we're going down this time. Correctly, going the right direction this time. All right, and we're going to connect our dots. Eye-hand coordination here. Nice. And we know we have 3 petals, so we're going to have 1, 2, 3. So we're going to pi again, which is really nice. All right, so let's read our polar points off the graph here. And remembering this is r and theta. So r and theta are both 0, so we're starting on the pole, which we suspected because it's the sine curve. And then we're going to go out radially -4, 1, 2, 3, 4, and rotate a positive pi over 6, which puts us right here. So we're going to go from the pole and go this direction. And then what happens from here? We go back to the pole. Before. There we go. And then we're going to go to the next point, which is going to be at 4. 1, 2, 3, 4. 3 pi over 6, which is up here. So we're going to rotate up here. And then we're going to go back to the pole. Back to the pole. And then we're going to go -4. 1, 2, 3, 4. And go out radially 5 pi over 6, which puts us here. So we're going to pass through the pole, hit the 5 pi over 6, and then come back to the pole at pi. So there we go. We have another rose curve with 3 petals of length 4. And where our max theta r is going to be at negative pi over 6. Yep, that makes sense. It's negative pi over 6 at pi over 2. Yes, and then a negative, over here, and then we go 5 pi over 6. So that works. All right, this next one. This one's a little bit more challenging, and I chose to do this one because, yes, it is an odd number, and maybe next time we'll work one where I have a period factor of 4, so we have 8 petals. But this one is a little bit more challenging because the period and the increments do not match our illustrious polar plane here. So I know that the period factor is b. So my period here is 2 pi over 5, which is weird, I know. And then the increment is going to be 2 pi over 5 times 1/4, because its period is over 4. So this will be 2 pi over 20, or pi over 10. And I'm going to change this to tenths, which would be 4 pi over 10. So I'm really scrunched together. My period here is not even pi over 2. So let's, my midline is still at 0, which is really nice with these rose curves. Now, how many petals are we foreshadowing that we're going to have here? We're going to have, I heard it, 5 petals. Okay, and my amplitude here is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, -5 here. And then I've got to label my curve. So I'm going to go out to 4 pi over 10. halfway, half, half. And so my increments are in pi over 10. So we're going to start at pi over 10, 2 pi over 10, 3 pi over 10. And then I'm going to put 8 pi over 10 here. And then we get 5 pi over 10, 6 pi over 10, 7 pi over 10. And I don't know if we have to go further. Let's see if we have to go further. Let's graph what we have first. This is a cosine curve starting up. Yes, it's starting up, back to the midline. Down, back to the midline, up, down to the midline, down further, back to the midline and up again. Here we go. We're going to graph our very compact curve here, trying to get every point. I missed it. I missed those 2 points. Oh no. We're going to hit our point. But we have to be on the same line. I'm doing this on purpose, you know, just so that you can have some time to graph your graph too. No, I'm not. I'm doing it because I'm not perfect. Okay, here we go. All right, so let's have a discussion about the polar plane. The polar plane, remember, is pi over 12. So this is what helps me when I'm graphing these. Remembering that this is r and theta. I know that pi over 2 is how many tenths? Oh, that's 5 pi over 10. And I know that pi is 10 pi over 10. Okay, and that's going to help a lot, I think, when we're graphing this. Okay, so halfway is 2.5 pi over 10. And pi over 10 is bigger than pi over 12. So that's going to be, you know, if I had to do a pi over 10, it's going to be in here somewhere, but less than pi over 6. So these are going to be approximations, and we have to be okay with that. All right, so what's our first polar point? Our first polar point is 5, 0. So we're going to go out radially 5. 1, 2, 3, 4, 5, 0. And then where pi over 10 is, which I'm going to put, this is pi over 12. I'm going to put pi over 10 right about here. Okay. Before I get to pi over 10, I got to get back to the pole. So it's kind of a skinny flower. All right, where am I ending up next? I pass through the pole and I have to go to 2 pi over 10. Well, 2 pi over 10 is going to be halfway, or just under halfway in some quadrant over here, okay? So I'm going to go out radially -5, 1, 2, 3, 4, 5, and I have to rotate almost halfway. So this is halfway, so I'm going to put almost halfway right here. And this is an approximation. It's okay to approximate when we have oddball fractions here. So I'm going to go through the pole and then end up here. And then what happens? I go back to the pole. Boom, back to the pole. I'm here now. Now we're going to go radially 5, out 5, and then we're going to rotate 4 pi over 10. Well, that's almost 5 pi over 10. But it's going to be less than, so it's going to be in here somewhere. Right, because this is a 12th. So tenths are going to be somewhere in the middle. Okay, so then I'm going to pass through here, hit this one, and then go back to the pole. So I'm going back to the pole. There I'm at the pole here. Now I'm going to go radially -5 again, and I'm going to rotate 6 pi over 10. Well, if halfway is 5 pi over 10, I'm probably going to be here somewhere because it's a little bit more than a 12th. So here we go. We'll rotate here, back to the pole again. That's 7 pi over 10. Now I'm going to go out 5 and rotate 8 pi over 10. Well, this is 10 pi over 10. Okay, 8 is 3 more than 5, which is just over halfway. So I think we're going to be maybe here. This is halfway. Wait, halfway is here, right? That's 2.5. So I'm going to maybe be here. Oops, I'm on the 6th line. I need to fix that. Okay, so we're going to rotate, pass it out through here. And then I don't show where I'm going, but what do we know has to happen? We got to go back to the pole. Here we go. I'm going back to the pole. And then I'm going to pass through the pole, and then we have to finish our curve, so I'm going to end up here. And okay, so this is half a petal. This is a full petal, full petal, full petal, half a petal. So how many did I have? 1, 2, 3, 4, and I'd have to go another full petal to get the rest of it. But okay, so which ones did we draw out first? And I should really use a different color so we can see it better. Well, we drew out this half first, and then where did we go? We went here, so this is 2, pass through the pole, and there, where was 3? It was here. Then we went down here, this is 4, this is 5, and then we ended up here. The 6 is half. So how many petals do we have? 1, 2, 3, 4, 5. We do, we have 5. So this is a rose curve with 5 petals of length 5. Now, I went out, I started off the pole, didn't I? So I started out and off the pole in the positive direction. If it was a negative cosine, I would be starting on this side. Okay? All right. And our max R's, I know that you can figure that out now. All right, so let's do another one. My increments are all the same, except now I'm doing a sine curve. So I'm going to go to 8 pi over 10, and then 4 pi over 10, and then we're in increments of tenths. So this is pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, 5 pi over 10, 6 pi over 10, and 7 pi over 10. Amplitude of 5. This is negative 5, and this is 5. So the sine curve, start on the midline, go up in amplitude, because I'm not negative. Back. It's like coming home, isn't it, when we're drawing sine curves again? You're like, hallelujah, these are so easy. We can do these. Okay. Remembering that this is r and theta, and my theta is counterclockwise because I'm going in the positive direction. Okay. This is on the pole. We start on the pole, and then we're going to go out radially 5 and rotate pi over 10. 1, 2, 3, 4, 5, which is going to be in here somewhere because it's between pi over 12 and pi over 6. And then we rotate out radially, and then we're going to go back to the pole. So we rotate 5. We go out radially 5 and rotate pi over 6, and then head back to the pole, and then we're going to go to negative 5. 1, 2, 3, 4, 5. And then we're going to rotate 3 pi over 10, which is just a little bit more than halfway. This is halfway, so I'm going to put it right here. So we pass through the pole, hit this point a little bit more gracefully than I was going to do, and then go back to the pole. So now we're at 4 pi over 10 at the pole. Then we're going to go to radially 5. 1, 2, 3, 4, 5, and then rotate a nice number, 5 pi over 2. So we're going to end up at, 5 pi over 10, which is pi over 2. I kind of mixed those two together. So we're going to pass through the pole, hit this, then come back to the pole. And I'm out 6 pi over 10 at the pole, because 5 pi over 10 was up here. Then I go out radially negative 5. 1, 2, 3, 4, 5, and rotate 7 pi over 10. Remembering that this is 5 and this is 10. 7 is just under half. So that's going to be right here. So we're going to pass through the pole, hit this, go back to the pole, and then we're going to go out radially. This is going to be symmetric. And then we're going to finish again. So that would be our sine curve, our rose curve. I know I'm going a little bit fast, but this video is getting a little long. With 5 petals of length 5. And I know that you could extend this a little bit and find some more points. All right, so which petal did we do first? Well, we did this petal first. So we did this petal first, and then we did this petal second, and then we did this petal third, then fourth, and then fifth. Right? Because this is petal 1, petal 2, petal 3, petal 4, and we would just do one more to do petal 5. All right. Cool beans. Now let's do something a little bit different because I had the rose curves, etc. Well, this is the etc. What happens if I have a curve that says r equals 3? Well, Mrs. Muller, there's no sine and cosine in there. Right. Well, we should like those things because they're less complicated. So if I were going to do an r theta for r equals 3, this means r is 3 all the time. So here it is. Here's my r is 3 all the time. Does it matter what theta is? No. Okay, so let's plot some points. 3 radially, rotate nothing. Let's just rotate pi over 2 just for kicks and giggles. 3 pi over 2. Go out radially 3, rotate pi over 2. Oh, let's rotate pi. Let's go pi. 3 pi. Oh, okay. Starting to look like something I might be familiar with. Are we getting the idea here? This is a circle. Oops, helps if I'm on the right radius here. Of radius 3, and it circles the pole. It never reaches the pole. Remembering that this is the pole. This is a radius of 3, and it's centered at the pole. Center is equal to the pole. Okay, now, we jokingly do not say this is a one-petal rose. It's not a one-petal rose, it's a circle, okay? Okay. Now, these are more interesting here. These curves here are squared. They're squared. All right, well, so let's see what r is if I take the square root of both sides. It would be 5 times the square root of cosine 2 theta. It would be plus or minus, okay? But we're going to deal with the plus first, okay? So this is cosine 2 theta. Remembering that the period factor here is 2, so the period is 2 pi over 2 or pi. Okay, so here's the period. This is pi, half, pi over 4, 3 pi over 4, and we're going to go to 2 pi here. 3 pi over 2 is halfway. 5 pi over 4, 7 pi over 4. Amplitude here is 5. Okay, now, I don't know what the square root of whatever this is going to be. It's going to be a number. It's going to be smaller than the regular cosine curve. But I know that I can't take the square root of what kind of numbers? Negative numbers. Okay, so I am going to draw this curve as if it was a cosine, but it's a square root of a cosine. So what happens when theta is 0? Well, when theta is 0, cosine is 1. So 5 times 1 is 5. So I'm going to start up here. And then I know that the cosine, when I plug in pi over 4, 2 times pi over 4 is pi over 2. The cosine of pi over 2 is 0. So I know I'm here. So I know I'm going down. And then what happens? Well, then I start getting some negative numbers under here. Okay? And so I'm going to draw my cosine curve, it starts here, as if I was drawing a regular cosine, although I know these values are going to be smaller than the regular cosine. And you'll see what I mean in a minute. So I'm graphing these dashed because they are not part of the curve because I can't take the square root of negative numbers. But I can draw the rest of the positive ones. Nice. Okay, so this is where the cosine of 2 theta is negative. It's less than 0 here. And I can take the square root of these numbers. Okay, these would be an imaginary number. So let's graph what we have. All right, well, I'm going to go out radially 5, 1, 2, 3, 4, 5, put a point. And then by pi over 4, which my angle here, pi over 4, I have to be back to the pole. So here we go. I'm going to go back to the pole. Getting smaller, back to the pole. Then I sit here for a while. And then I'm going to go out from the pole. What happens here? Because I'm still at the pole. Okay, then I'm going to go out radially 5 again and rotate pi. from here. So in effect, I'm bouncing here at the pole. So I'm going to put my other angle here so I can see it better. So I'm going to go outward to here. So it's like I'm bouncing off the pole here because I can't take the negative number square roots. So this is really a bounce in disguise. So that's the top part of the curve. And now where am I? I'm here. Then I'm going to go back to the pole. And then I'm going to bounce off the pole again and then end up here, which is 5 rotating 2 pi. So there's our best friend, infinity. This is a lemniscate. Fancy word for an infinity symbol. And this is with width, loop length. There's some alliteration there. Lemniscate with loop length of 5. Okay? And what's happened when you take the square root is effectively we're taking, the top and the bottom parts off here, the petals off because we can't take the square root of negative numbers. Okay? All right, so let's do another one with the sine curve. So I get r equals plus or minus 5 times the square root of sine of 2 theta. All right, so we're going to do the same thing. Here's my midline. I'm going from 0, and we're going to go all the way to 2 pi because it gives us the whole curve. And pi here, we get pi over 4, pi over 2, 3 pi over 4, half, half, half. And then we get 5 pi over 4, 3 pi over 2, 7 pi over 4. Okay, and we're going to go up 5 and down 5. 1, 2, 3, 4. So this is negative 5 and this is 5. And I'm starting at the pole because this is a sine curve. And I'm going to do the same thing with my sine curve, knowing that these values are a little bit smaller. But what I'm going to do is dash the negative ones because I can't take the square root of what kind of numbers? Oh, negative numbers. Here we go. So here's the first part. Here's the second part. And then these are just, whoops, I should have been under 3 pi over 4 here. These are just dashed because, why? The sine of 2 theta is less than 0 here. I can't see what I did here. And I can't read what I did, so let's rewrite it real quick. Sine of 2 theta, I should say. 2 theta is less than 0. So let's graph it. We're going to start on the pole. And we're going to go out radially 5, 1, 2, 3, 4, 5, and rotate pi over 4, which is in the middle. So we're going to go out radially, rotate pi over 4, and then we're going to go back to the pole. And then what happens? I have to start out at the pole again, and then we're going to go out to, what is this, 5? 1, 2, 3, 4, 5 out here, and then we're going to go 5 pi over 4, which is over here. And then back to the pole again. So this is a lemniscate again with loop length of 5. Now what happened was I went out here like this, and then I bounced on the pole again, but I went outward this way. So this is another bounce, right? So we go all the way out here, but then we're going to bounce at the pole and then come back and do this. Okay, and that's a lemniscate there of loop length 5. Okay, and we're gonna graph those in just a minute on the Desmos before we sign out. Okay, well, what about this one? This is r equals theta. Well, that's almost like y equals x because this is r and this is theta. So I'm gonna graph a line like this. Okay, so let's plot some points. Well, obviously this is the pole. And then let's say I'm at pi over 2. Well, what is this point? Well, this point is, well, Mrs. Mother, it's pi over 2, pi over 2. You're right. What about pi? Well, this point would be pi pi. I just like saying that, pi pi. And so on, right? And our last point might be 2 pi pi. 2 pi, 2 pi. So let's plot these points. I'm going to go out radially nothing and start at the pole. Then I'm going to go out radially pi over 2. Well, what is pi over 2? Well, pi over 2 is about 1.571. So we're going to go out 1.5, maybe, roughly, and then rotate to pi over 2. So we're going to end here. So what's happening is r is getting bigger until I get to pi over 2. There we go. Then we're going to go out radially pi, which is 3.1415, 1, 2, 3. So it's out here somewhere, and then I rotate to pi. So 1, 2, 3, right, maybe right about here. So we're going to, r is getting bigger. So we're going to rotate. That was awkward. It should be a smooth, transition there, not like a bump. Okay. And then if I were to go 3 pi over 2, 3 pi over 2, 3 pi over 2 is about 4.71. So 1, 2, 3, 4, 5. So something here, and then we're going to go to 3 pi over 2 down here. So down here, maybe right about here. Do you see what's happening? And then 2 pi, 2 pi. 2 pi is 6.28 roughly. So we're going to put that out here. Well, Mrs. Muller, you're spiraling out of control. Yes, I am. Yes, this is a spiral. So if you have r as some kind of function of theta without a sine or a cosine, you're going to have a spiral of some sort, which is kind of cool. All right, I'm going to end this lovely presentation with our Desmos here. And the biggest question I'm going to get is, well, Mrs. Muller, when we did that 5 square root of cosine of 2 theta, there we go. I'm going to make it smaller so we can see our lemniscate. And our petal, our loop length is 5. But you might say, well, Mrs. Muller, we didn't use the negative one. What happens with the negative one? Well, let's put the negative one in here just to show you. R equals negative 5 square root cosine 2 theta. Ooh, I cannot spell with a flip. Here we go. Wow. Oh my gosh. Are they the same curve? They are the same curve. Well, what's happening is that you're rotating the other direction. You know how we started off on this side over here and went and bounced off like this? Yeah, well, we would go the other direction, right? We'd start at negative 5 and then bounce off here and go this way. So if we started with the positive square root of cosine 2 theta, we started this way and then we went to the pole, bounced off, and came this direction. If we started at negative 5, we would start here, bounce off the pole, and end up here. We're still going counterclockwise because our angles are getting more positive. So we're taking care of the negative. We're just rotating it a different direction if we choose this version of the r. So we're not like ignoring the plus or the minus, okay? So you can choose one or the other. All right, so I'm going to do our r equals theta just for fun and for you to watch me spell incorrectly again. There's our spiral. And with that, you see that I'm spiraling out of control. The Desmos doesn't even want to be any bigger than that. We're spiraling out of control, and I'm going to end this fun talk on polar graphing and rose curves, etc. You have a great rest of your day.